Welcome to C and C++ programming under EPG Pathshala. Today we will start with module control structures. Till now we have seen small C++ programs where the programs was executed sequentially one after another starting from the main function. So, whenever the program starts execution, the control was given to the main function one after another till the end of the main function. The statements were executing in sequence. Control structures gives you the flexibility to change this control flow, where the program execution can be controlled using the control structures. In real life also, we come across many situations where depending on the condition, we decide whether to go left or right, or there are many options and we have to choose one of them, or there are many pleasant situations in our life which we want them to repeat again and again. In the same way, control structures gives you the flexibility to alter or to change the program flow, where depending on the condition we can change the execution flow. Some statements can be omitted completely, some statements can be executed only once, or some statements can be executed again and again. There are three basic control structures which are provided in C++. Those are straight line execution, second selection execution, and third one is a looping structures. Now let's start with the module and see each one of them in detail. Normally in C++ program, the statements in a program execute one after the another in the order in which they are written. This is called as sequential execution. Various C++ statements will enable you to specify that the next statement to execute may other than the next one in a sequence. This is basically called as a transfer of control. This is achieved by using the selection structure or a repetition structure. C++ provides three types of selection structure. The if selection structure either perform an action if a condition is true or skips the action if the condition is false. The if else selection structure performs an action if a condition is true or performs a different action if the condition is false. The if statement structure is a single selection structure. It selects or ignores a single action. The if else selection structure is a double selection structure. It selects between two different actions. The switch selection structure performs one of many different actions. Depending on the value of an integer expression, the switch selection structure is a multiple selection structure. It selects the action to perform from many different actions. C++ provides three types of repetition structures, also called as looping structures or loops, namely while, do while, and for loop. A repetition structure allows the programmer to specify that program should repeat an action while some condition remains true. Objective of this module: first we will learn about the selection statements if, else and switch. Study about the iteration statements for, while, do while. Get familiar with jump statement, break, continue and exit function. Study about unconditional branching statement, go to and continue. Now let us see what are control structures. The statements those are used to control flow execution in the program are called as control structures. The control structures are used by the programs to implement the program logic. In general, there are three types of control structures. They are sequence structure, selection structure and loop structure. Now let us see each one of them in detail. Sequence structure refers to the instructions that are executed in the sequence in which they are written in the program. Example: the compound statement, opening bracket, the statement 1, statement 2 and so on, and the end of the bracket. Selection structure is a structure which selects which statement or a block of statements will execute on the basis of the logic of the program. Examples are if statement, if else statement and switch statement. Loop structures are the structures which are used to go over the statements or the set of statements. Example are for loop, while loop and do while loop. Now let us start with the selection statement if. A selection statement selects among a set of statements depending on the value of a controlling expression and causes the program control to be transferred to a specific flow. The selection statements are used to make one-time decisions, that is, to execute some codes and ignore some codes depending on the test condition. The selection statements that are supported by C++ language are if else, nested if, switch and nested switch statements. Now, let us see each one of them in detail. First, we will start with the if statement. The if statement consists of a Boolean condition followed by one or more statements. The syntax is if condition in curly braces the block of statements. Here the statements will be executed if the condition is true. In the if statement, if the condition is evaluated to true, then the block of code inside if statement will be executed. If the condition evaluates to false, then the first set of code after the end of if statement will be executed, and it is shown nicely in that particular flow chart. Now, let us see a simple program to implement the use of the if statement. We will start with the program hash include IOStream using namespace std. We will start with the main function. Here one variable of character is declared char ch. We are displaying the message to the user cout enter a character. We are taking the input from the user as cin ch. Now we are checking whether the user has entered the character or a digit. So our condition of if condition will be if ch greater than equal to 0 and ch less than equal to 9, then cout display the message the digit is entered and end of the if statement and end of the main program. When the above code is compiled and executed, it will first display the message enter a character. If you enter the digit 5, it will display the message the digit is entered. Now let us see one more program to check whether the given number is even or not. We will start with the program hash include iostream.h using namespace std. We will start with the program integer main, the start of the main function. Here we will declare one variable as integer num. We will display the message to the user as cout enter a number. We will take the input from the user as cin number. Now the input number we are going to check whether it is odd or even, and the condition that we are going to check is if the remainder is 0 or no. And for the remainder to check whether it is 0 or no, the operator in C++ that we are going to use is mod operator. So our if condition will follow here. If num mod 2 is equal to 0, then we will display the message cout the num is an even number, and we will end with the if bracket and will end with the main program. Now when the above code is compiled and executed, it will produce the following result: enter number. If you enter the number as 4, it will display the message as 4 is an even number. Now let us start with the program to find out the maximum of 3 numbers using the simple if statement. We will start with the program hash include iostream.h. Next one is using namespace std. Now we will start with the main function main opening and closing bracket. First we will declare the variables integer x, y, z and the max. Here the max variable will store the maximum between 3 numbers x, y and z. Now we will display the message to the user using the cout statement cout enter 3 values. Then we will take the 3 inputs from the user as cin, x, y and z. Now we will start with our program logic. The first number will assign it as a maximum. So our statement will be max equal to x. Now we will check whether the second number is greater than max or no. Now here we will use a simple if statement. If y is greater than max, if this particular condition is true, then we will start with the main bracket and we will assign the y number to the max as max equal to y. Our if condition ends. Now we will check whether our third number is greater than max or no. So our simple if statement will follow here. If z is greater than max, then max will be equal to z, the bracket completes. So here either x will be maximum number or y will be maximum number or z will be maximum number, and at the end we will display cout the maximum between x, y, z and the value of the max, and our program will end here. After executing and compiling this particular program, it will display the message as enter 3 numbers. Suppose the 3 numbers are 10, 100 and 20. It will display the maximum as 100. So, this is a simple program of finding out the maximum of 3 numbers using the if statement. The next is the if-else statement. The if-else statement executes the body of if when the condition is true and executes the body of else if the condition is false. The syntax is if boolean condition, then the set of statements, else, start with the curly braces, the set of statements if the boolean condition is false, end of curly braces. Now, let us understand the if-else statement using the simple program to implement the if-else statement. We will start with the program #include iostream.h using namespace std. Now, we will start with the main program integer main, start with the program. Here we are declaring the integer a as 100. So, we are initializing the variable a. Now, we are checking if a value is less than 20, we are displaying the message as inside the if condition cout a is less than 20 and L if condition ends. Now, we will have a else part of this particular if condition, else cout n is not less than 20 and L and the else function or the else part ends. Next, outside if-else statement, we are having the statement as cout the value of a is a and L return 0, our main program ends. Now, here the condition will be checked for the value of a. If it is less than 20, the true part will be executed, and if it is condition is false, then the else part will be executed. When the above code is compiled and executed, it will produce the result as a is not less than 20 and the value of a is 100. So, here we are not taking the input from the user, but we have assigned the value 100 to a. So, our first condition a less than 20 is false. So, it will display the message a is less than 20. The nested of if statement. One if statement has another if inside its body, then it is called as the nested if statement. There are 3 basic variations of the if statement which can be nested in a different fashion. The first form is, the syntax is if expression 1, inside that if expression 2, the statements else statement 2, else body of the else part and end. So, here inside one if the another if is specified. The second form is if expression 1, the body of if, else if expression 2, the statement 1, else statement 2 and the end of all if statements. Here both the parts are given, the true part as well as the false part. The third form is if expression 1, inside that if expression 2, the statement 1, else statement 2, main big if else, if expression 3, statement 3, else statement 4. Here for the if part, both the part true and false part are specified. Now, let us see the program to implement the usage of nested if statement. Here we are going to see a simple program where the nested of if statement is done. We will start with the program #include iostream.h using namespace std. We will start with the main function main opening bracket. Here we will declare the variable number as integer number. We will take the input from the user. So, first we will display the message cout enter a number, cin number. Now, we are going to start with the nested if structure. Here we are checking the value of this particular input number. If number is greater than 100, inside that we are checking if it is greater than 500, inside that we are checking if the number is greater than 10,000, then we are displaying the message as cout/n num too high. If the number is less than 1000, then we will display the message as the number is medium. Now, here if condition, 2 if conditions will end, the third if condition will also end, and outside that we will have one more if condition. If number is less than equal to 500, then we will display the message as cout the num is low. Now, outside that again we will have a if condition. If number is less than 100, then we will display the message as cout the num is too low, and our if condition, all the if condition will end and our main program will end. Now, here what we are checking? We are checking in a nested if whether the number is greater than 100, 500 or it is greater than 10,000. So, we are checking the number inside the range, whether it is greater than 10,000, whether it is between 500 to 1000, whether it is less than 500 or whether it is less than 100. So, these are the 4 ranges in which the number is basically checked. When the above code is compiled and executed, it will produce the following result as: enter the number. If the number entered is 75, the message will be displayed as 75 is too low. If again the input is given as enter a number 50,000, then the message will be displayed as 50,000 is too high. So, this particular program basically checks whether your input number is too low, high, medium or too high. We can again have the nesting of a if-else statement. The if-else-if ladder. It is a common programming construct in C++. It is also called as if-else-if staircase because of its appearance. The syntax will be if expression statement 1, else if expression 2 statement 2, else if expression 3 statement 3, else statement n. So, here one if else can appear in the another fashion, one inside the another. Here the expressions are evaluated from top onwards. As soon as an expression is evaluated to true, the statement associated with it is executed and the rest of the ladder is avoided. If none of the expressions are true, then the final else will get executed. Now, let us see a simple program to implement this particular usage of if-else-if ladder. We will start with the program #include iostream.h. Using namespace std, we will start with the main function. Here the character is declared as char ch and there are 3 float variables declared: float, a, b and result. We are displaying the message to the user, enter any 2 numbers, and we are taking 2 numbers from the user as C in A, B. Now, here we are displaying the message to the user, enter the operator plus, minus, star and slash, and we are taking the operator into the character variable C in CH. So, here 2 input numbers has been accepted and 1 operator in a character CH is accepted. Now, we are checking whether the character that is entered or the operator that is entered is plus or minus or star or slash. So, here we are going to use the nested of if-else-if ladder. So, here we are going to start with the first. If CH is equal to plus, then the result will be A plus B. We are going to add the 2 variables. Else, if the CH is equal to minus, then the result will be A minus B. Else, if CH is equal to star, then the result will be A star B. Else, if CH is equal to slash, then the result will be A divided by B or A slash B. And finally, outside this if-else ladder, we are displaying the message as cout/n. The calculated result is the result, the value of the result, return 0 and our main program ends. When the above code is compiled and executed, it will produce the result as enter any 2 numbers. Suppose the user number enters the number as 10 and 15. Next message that will be displayed is enter the operator plus, minus, star and slash. Suppose the user has entered the operator as plus, then the calculated result is 25, where the 2 numbers 10 and 15 is being added. The next selection statement is a switch statement. It is used to perform the code from multiple conditions or case. It is similar to if and else if ladder statement. It works with byte, short, character and integer primitive data type. It also works with enumerated types and string. It can only work for equality comparisons. There should be no 2 case labels in the same switch which consist of identical values. But in case of nested switch statements, the case constants of an inner and outer switch can consist of common values. If character constants are used in the switch statement, then they are involuntarily converted to their integers, that is their equivalent ASCII codes. It is a must that a break statement must be present after the last case statement in a switch. Syntax is switch in bracket expression of variable, opening braces, the case value colon, the statements, break, default, colon, statements, end of curly braces. Let's see a simple program to perform addition, subtraction, multiplication and division of two numbers using the switch statements. We will start with the program hash include iostream.h, hash include stdlib.h. Using namespace std, we will start with the main function integer main. Here we are declaring three variables as integer a, b and ch. We are displaying the message to the user, enter any two numbers. We are taking the input from the user as C in A, B. Now we are displaying the menu to the user using the cout statement. Cout 1 for add, cout 2 subtract, cout 3 multiply, cout 4 divide, cout 5 exit. Now we are asking the choice from the user. Cout, enter the choice between 1 to 5. We are taking the input as C in ch. So here the user will give the menu option between 1 to 5. We are displaying the /n, that is a new line character, and now we are having the switch statement switch ch. So the value entered will be compared with each of the case labels. Start with the switch statement case 1. Case 1 is basically the addition. So we are displaying the message as cout result equal to a plus b /n, that is a new line, and break. Case 2, cout result equal to a minus b /n and the break statement. Case 3, cout result equal to a star b /n and the break statement. Case 4, cout result equal to a /b /n and break statement. And case 5, exit 1. Default, cout wrong choice, press any key to exit, break. Here we are ending with the switch statement, return 0 and the end of the main function. Now here as you can see, we have used the switch case statement. The case 5 is basically to come out of the program, and default, if the option is not between 1 to 5, it will go to the default range or the default value and it will give the message as wrong choice. When the above code is compiled and executed, it produces the following result: enter any two numbers. Suppose the entered numbers are 10 and 2, then it will display the message enter the choice 1 to 5. Suppose the choice is 1, then the result will be addition of two numbers 10 plus 2 12. Now let us see a program to implement the usage of nested switch, that is one switch inside the another switch. Hash include iostream using namespace std, integer main. Here we are initializing two variables of type integer, integer a equal to 100, integer b equal to 200. Now we are starting with the switch statement, switch a. Inside that case 100 colon, we are displaying the message cout outer switch end L. Then inside that particular case label, we are having one more switch statement, switch b, starting curly braces, case 200 colon, cout inner switch end L. The inner switch statement ends and the outer switch statement ends. And now we are displaying the value of a, cout exact value of a is a, cout exact value of b is b, return 0 and our main program ends. Now here as you can see, one switch is nested inside the another switch. When the above code is compiled and executed, it will produce the result as the part of outer switch, then it will display the message the part of inner switch, then it will display the message exact value of a is 100 and exact value of b is 200. Iteration statements. The iteration statement allow a set of instructions to be executed repeatedly until a condition is fulfilled. The iteration statements are called as loops or looping statements. C++ provides three kinds of loops. They are for loop, while loop and do while loop. The three loop constants of C++ repeat a set of statements as long as the condition is true. In general, a loop has four elements. They are initialization expression, test expression, update expression and the body of the loop. Now let us see each one of them in detail. Initialization expression. It is a must to initialize the control variable in the beginning of a loop. The initialization of control variable takes place under initialization expression. The initial value to the loop variables are specified by using the initialization expression. The initialization expression will be executed only once in the beginning of the loop. Text expression. The text expression is an expression whose truth value makes a decision whether the body of the loop will be executed or no. If the text expression evaluates to true, then the body of the loop gets executed. Otherwise, when the text expression evaluates to false, then the loop is terminated. In general, there are two types of loops. They are entry control loop and exit control loop. In an entry control loop, the text expression is evaluated before exiting from the loop in the beginning of the loop. Whereas, in case of exit control loop, the text expression is evaluated in the ending of the loop. In C++, the for loop and while loop are considered as entry control loops, whereas do while loop is considered as exit control loop. Update expressions. The update expression help in altering the value of the loop variable. The update expression is executed at the end of the loop after the body of the loop is executed. The body of the loop contains the statements that are executed repeatedly as long as the text expression is true. In an entry control loop, the first text expression is evaluated, and if it is true, then the body of the loop is executed. If the text expression is evaluated to be false, then the loop is terminated. In an exit control loop, the body of the loop is executed first and then the text expression is evaluated. If it evaluates to be false, the loop is terminated, otherwise it is repeated. The next is a for loop. It is a repetition control structure that allows you to efficiently write a loop that needs to carry out a precise number of times. The for loop can be used in situations wherein the block of the code is to be repeated specific number of times. As you can see in the flow chart, it will start with the initial condition. If the condition is true, then the code block is executed, the increment operation will take place and again the condition is checked. Whenever the condition becomes false, it will come to the end part. The syntax is for the init statement, next is a condition statement, next is a increment or decrement, starting of the for loop, the block of statements, end of the for loop. Now let us understand each part of the for loop. The init step is executed first and it is executed only once in the beginning of the loop. This step will permit the state and initialize any loop control variable. Even a single statement is not supposed to take here as long as the semicolon appears. Condition is evaluated. If the condition is true, then the body of the loop is executed. If the condition is false, the body of the loop does not execute and flow of control skip to the next statement just after the for loop. Increment or decrement. The flow of control jumps back up to the increment and decrement statement after the body of the loop executes. This statement allows to revise loop control variables. This statement can be left empty as long as semicolon appears after the condition. The condition is now evaluated again. If it is true, the loop gets executed again and the process repeats itself. The for loop terminates after the condition becomes false. Now let us see a simple program to print the numbers from 1 to 10 using the for loop. We will start with the program #include iostream.h using namespace std, integer main. Here integer I is declared. Now we will start with the for loop I is equal to 1, which is basically the initialization statement. I less than equal to 10 is a condition, I plus plus is the increment part, and inside for loop we are writing the statement cout I and end L, and we are ending with the main program. Now here when the for loop is executed, first the initialization will take place I equal to 1. It will check the condition 1 is less than equal to 10, the condition evaluates to true, so it will execute the statement cout I. Here the I value 1 will be displayed on the screen, and then the cursor will go to the next line because of the end L statement. After this I value will be incremented, which will become 2. Now the condition will be tested, 2 is less than equal to 10, the statement will be executed cout, the value that will be displayed on a new line will be 2, and so on. Now after this the increment will take place, condition will be tested and the statement will be executed. At the last, whenever the I value becomes 10, the condition is true, So, the last value that will be printed will be 10. I value will be incremented to 11. 11 is not less than equal to 10. So, it will come out of the loop. When the above code is compiled and executed, it produces the result as the series 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let us one more program to print the value up to a given number as entered by the user. We will start with the program hash include IOStream using namespace std, integer main. Inside that we are declaring the variable integer a. We are displaying the message to the user, enter the number, take the input from the user as C in A. Now, we are going to have a for loop. For inside the for loop we are displaying or declaring the variable as integer counter equal to 1, counter less than equal to A, counter plus plus, C out, execute, counter value we are displaying and the time that we are displaying, end L, that is the cursor will go to the next line, for loop ends and main program ends. Now, when the above code is compiled and executed, it will produce the result as enter the number. If the number entered is 5, it will display the line as execute 1 time, execute 2 time, execute 3 time, execute 4 time and execute 5 times. Now, let us see a program to find a factorial of a number using the for loop. We will start with the program IOStream using namespace std, integer main. We are displaying the variable as I n of type integer and factorial we are giving the initial value as 1. We are displaying the message to the user, C out, enter a positive integer. We are taking the value from the user as C in n. We are writing the for loop for I equal to 1, I less than equal to n plus plus I, and inside the for loop our statement is factorial star equal to I, that is nothing but factorial equal to factorial into I. Outside the for loop we are displaying the message as factorial of the factorial number. We are displaying the value of a factorial, return 0, our main program ends. Now, here when the above code is executed and compiled, it will produce the result as enter the positive integer 5, then it will display the message as factorial of 5 is 120. The while loop is known as an entry control loop because the condition is checked at the top of the loop. If the condition is false, the loop will not be executed, not even once. Syntax while, condition and in curly braces the statements. Now, let us see a simple program to see the usage of the while loop. Hash include IOStream using namespace std, integer main, we are initializing the variable a, integer a equal to 10, while a less than 20. Inside while loop we are displaying the message C out, value of a and the message value of a and the value of variable a, end a plus plus and our while loop ends, return 0. Now, here as you can see initial value of a is 10. So, our first condition 10 less than 20 is true. So, it will display the message value of a colon and the value 10. Now, a value will become 11, again it will go for the condition, it will check 11 less than 20, such way the loop will be executed till the value 19. Whenever the value of a becomes 20, our condition will be false and it will come out of the for loop. When the above code is executed, it will produce the result as value of a 10, 11 up to 19. Now, let us see the program to print the multiplication table for a given number using the while loop. We will start with the program hash include IOStream using namespace std. Here in main program we will declare the variables as integer num equal to 6, value and I. See out the multiplication table for num and L. I value is initially 1, while I is less than equal to 10. What we are doing inside the while loop is value equal to num into I, and we are displaying on the screen the message C out num star I equal to value I plus plus. We are ending with the while loop, we are ending with the main program. Now, when the above code is compiled and executed, it will result as 6 into 1 equal to 6, next line 6 into 2 equal to 12, complete the table of 6 up to 60. Now, let us see a simple program to print the Fibonacci series using the while loop. We will start with the program main. Our variables will be a equal to 0, b equal to 1, c equal to 0 and limit. we are displaying the message to the user, how many terms the user wants. We are taking the input as C in limit. We are outputting the message as Fibonacci series A and B. A and B are basically 0 and 1 values, which are the first two terms that we are displaying on the screen as it is. Next, C equal to A plus B, limit equal to limit minus 2. Here we are decreasing the limit by 2 because two numbers are already printed. Now our loop will be while limit, inside that C out C. Now we are saying A equal to B, B equal to C, C equal to A plus B, and limit minus minus. Our while loop ends and return 0, our main program ends. When the above code is compiled and executed, it will produce the result as up to how many terms. If the input is 5, the Fibonacci series will be printed as 0, 1, 1, 2, 3. Next is a do while loop. Do while loop is an exit control loop. The do while loop executes the statements inside the body of the loop at least once, even if the condition is false, because the condition is checked at the end of the loop. The syntax is do, opening curly braces, the statements, end of curly braces, while condition. Now let us see a program to print the characters A to F using do while loop. We will start with the program, main program, character CH, initial value we are giving as a capital A, do, opening braces, C out, /n, CH, then we are doing CH plus plus, and after the do, the while condition is specified, while CH is less than equal to F, return 0. Here the initial value of CH is A, which will be displayed on the screen. The character will be incremented by 1, so it will be becoming B. We are checking B is less than equal to F. If the condition is true, it will display it on the screen. So the characters that will be displayed on the screen will be A, B, C, D, E, F on a new line. Now let us see a menu driven program using the do while statement. Here the program will calculate the area, perimeter, diagonal of a rectangle using do while loop. We will start with the program, main. The characters has been declared CH, CH1. The float variables are L, B, peri, area and diagonal. C out, the rectangle menu that is displayed to the user is 1 for area, 2 for perimeter, 3 for diagonal, 4 for exit. We are taking the value from the user as enter your choice. Now the do loop will start. We are taking the value from the user C in CH. Now we will start if choice is equal to 1, 2 or 3. We will display the message to the user, enter the length and breadth. We will take the values as L and B. Now we are going to start with our switch statement. Switch CH, case 1, we are calculating the area as L into B. We are displaying that on the screen, and the break statement. Case 2, perimeter will be 2 into L plus B. We are displaying the value on the screen and we are coming out of the loop, break. Case 3, the diagonal will be square root of L into L plus B into B. We are displaying C out diagonal equal to the value of the diagonal and break. Case 4, exit 1. Default, we are displaying the message, the wrong choice and break. Here our switch statement will end. C out, we are displaying the message to the user, want to enter more, yes, no. We are taking the choice as CH1. If choice is equal to Y, small y or capital Y, C out, enter your choice again, and here the while condition will come, while CH1 is equal to Y or CH1 is equal to capital Y, return 0, main program will end. Here in this particular program, we had used do while statement, do while loop, and we had used the switch statement. So nesting of a statement with the loop is also illustrated. When the above code is compiled and executed, it will display the menu as 1 for area, 2 for perimeter, 3 for diagonal, 4 for exit. If our choice is 1, it will ask for length and breadth, and it will display the area as 20. It will again display the message, want to enter more. If the value is yes, again the choice will be asked. If the choice is 2, it will ask for the length and breadth. Suppose the values are 10 and 3, it will display the perimeter value as 26. It will again display the message, do you want to enter more? Now, if the choice is no, it will come out of the program. Now, let us see a difference between two loops, while and do while. While is a entry control loop, whereas do while is a exit control loop. The condition is tested in the beginning of the loop in a while. the condition is tested at the end of the loop in do while. If the condition is false, the statements inside the body of the loop will be not executed at least once. So, here the statements will be executed 0 number of times. Do while, even if the condition is false initially, then the statement inside the body of the loop will be executed at least once. Nested loops. A loop within another loop is called as a nested loop. In a nested loop, it is a must that an inner loop must terminate before the outer loop. We can have any level of nesting with a statement, with a loop, everything. Basically, C++ allows 256 levels of nesting. We can have a nesting of a for loop, we can have a nesting of a while loop, we can have a nesting of do while loop. Now, let us see a program to implement the usage of a nested for loop. Here, we are trying to display the pattern of star, star, star on the screen. So, start with the program hash include iostream.h using namespace std, integer main will declare two variables I and j. Now, two nesting of for loops will start. For I equal to 0, I less than 7, I plus plus. Inside that, again one more for loop. For j equal to 0, j less than equal to I, j plus plus. We are displaying C out star and end of the inner loop. Before ending the outer loop, we are having the message C out slash n, return 0 and main program ends. Here you can see the outermost for loop is basically for the lines and inner for loop is basically for the columns. When the above code is compiled and executed, it will produce the following pattern as star, on a second line 2 star, on a third line 3 star and so on up to 7 lines. Now, let us see the jump statements. The jump statements are used to modify the flow of control unconditionally. The jump statement shift the program control inside a functional unconditionally. The jump statements that are supported by C++ language are break and continue statements. Sometimes, based on the functionality of the code, the standard library function exit can be used to jump out of the entire program itself. The break statement is broadly used in loops and switch statements. A break statement instantly stops the loop or the switch statement and it avoids the remaining statements. The control then passes to the statement that immediately follows the loop or the switch statement. A break statement can be used in any of the 3 loops. When a break statement is used in a nested loop, then it affects only the inner loop in which it is used and its functionality will not be in any of the outer loops. In case of nested loops, one loop inside another loop are used, then the break statement will stop the execution of the innermost loop and start executing the next line of code after the block. When a break statement is used in a switch statement, it breaks out of that switch statement and not out of any loop that contains the switch statement. The syntax is a simple break statement followed by the semicolon. Now, let us see a program to implement the usage of the break statement. Hash include iostream using namespace std. We will start with the main program, integer a equal to 10, do cout statement, value of a, the message and the value of a is equal to a plus 1. If a is greater than 15, then we will have a statement break. Now, while a less than 20, return 0, main program ends. When the above code is compiled and executed, it will display the result as value of a is 10, value of a is 11, value of a is 12, value of a is 13, value of a is 14 and value of a is 15. The continue statement. The continue statement is used to continue the loop with its next iteration. The continue statement simply skips any leftover statements that are present in the current iteration and it tries to immediately passes to the control to the next iteration. The continue statement does not stop the loop as in case of break statement, but it only terminates the present iteration of the loop. A continue statement can be used in any of the 3 loops. In case of for loop, the continue statement causes the qualified test and increase portion of the loop to execute. In case of while and do while loops, the continue statement causes the program control to pass to the conditional test. The syntax is continue and semicolon. Exit function. The break statement allows to break out of loops. In the same way, the exit is a library function which is used to come out of the program. The exit function causes the program to terminate as soon as it is encountered it return to the operating system. The return code with the value 0 exit a program without any error message, but other codes designate that the system can handle the error messages. The syntax is void exit integer return code. Let us see the program to check whether the number is prime or no using the statement exit. Hash include IOStream, hash include stdlib using namespace std, integer main will start with the program, integer num and I, we are displaying the message to the user, enter the number, we are taking the input as cout num, cout the number is num. Now we are starting with the for loop for I equal to 2, I less than equal to num by 2, I plus plus. If num mod I is equal to 0, we are displaying the message not a prime number, exit 0, end of if condition, end of for loop, cout it is a prime number, return 0 and end of the main program. As you can see here, once you find that number is a prime number, it will not go to the next iterations, but it will come out of the program. When the above program is compiled and executed, it will produce the result as enter the number. If the number is 27, then it will display the message as the number is 27, not a prime number. Unconditional branching statement goto. The goto statement is used in many of the programming language to move in backward and forward direction in the program. The goto statement can be used anywhere within the function or a loop. The goto statement transfers the control from one part to the another part in the program, which is specified by a label. The labels are user defined and they are identifiers followed by a colon that are prefixed to a statement, which are used to specify the target of a goto statement. The goto statement is used for unconditional branching or transfer of the program execution to the label statement. The syntax is statements goto name of the label semicolon. Now the name of the label semicolon and the statements. Now let us see the simple program to see the usage of goto statement. Hash include IOStream using namespace std, integer main, integer x equal to 10, the loop colon cout x minus minus. If x is greater than 0, go to the loop, cout example of goto return 0. Now as you can see in this particular program, when the code is compiled and executed, it will produce the result as initial value of x 10, then it will go till 9, 8, 7, 6, 5, 4, 3, 2, 1. These are the values that will be displayed on the screen, and then it will display the message example of goto and the program will end. Now let us summarize the module control structures. As we have seen, control structures provides the structures to implement the program logic. In sequence control structures, the program is executed sequentially one after the another. In selection control structures, depending on the condition, a group of statements is selected for the execution, and in loop control structures, some loops or the some statements are repeated again and again for the execution. In selection statements, there are three statements which are provided by C++ language. Those are if statement, if else statement and the switch statement.